Hello and welcome to 3.2, the product and quotient rules. We start off with the product rule. Okay, so in this one we're looking at the product rule. It's a special formula involving the product of two functions and how we take the derivative for that product. Okay, one of the things we'll notice here that the derivative of a product is not the product of the derivatives. Okay, it's not like the sum or the difference rules. So for example here, if we have f of x equals x and g of x equals x squared, when we do the product of f of x and g of x, and when we do f times g, we get x times x squared, which is x cubed. Now if we take the derivative of this with respect to x, we end up with 3x squared. If we take the derivatives individually, so derivative of x becomes 1, derivative of x squared becomes 2x, and then we multiply them, we don't get the same result. Okay, so we cannot say that the derivative of a product is the product of their derivatives. Okay, so don't fall for that trap. Okay, so let's take a look at what the product rule is. Okay, basically it's written like this. There's a shorter way of writing it, which I'll introduce in a minute. But basically it's the derivative of a product of two functions is the first function. Okay, so it's equal to the first function times the derivative of the second function plus second function times the derivative of the first function. Okay, that's basically what our product rule is. Okay, when it's an f of x and g of x, it looks a little bit longer than what it is. Let's see the shorter version. So here we have derivative with respect to x of two functions, call them u and v. Okay, so its derivative is equal to u times the derivative of v plus v times the derivative of u. Okay, it equates to the same thing. Okay, so let's use the product rule here. It says if f of x equals x e to the x, find f prime of x. Okay, so we're going to do derivative with respect to x of x times e to the x, which will mean we'll do the first function. So first function is x. If you want to think of first, and then second function would be e to the x. Okay, so that means we would take the first function, x, times the derivative of the second function. Now, derivative of e to the x, we learned earlier, is e to the x plus second function, e to the x, times derivative of the first function. Now, derivative of x is 1. Okay, simplify it a little bit, we'll remove the parentheses. So this becomes x times e to the x plus e to the x times 1 is just e to the x. Okay, so that's our derivative. Okay, next it says find the nth derivative. Okay, so if we're going to keep going with this, let's see if there's a pattern established. Now, what we could do to help ourselves is let's factor out e to the x. That might help us with the, okay, this is our first derivative. Let's factor out e to the x. So we would have e to the x and then times x plus 1. Okay, or you could say x plus 1 times e to the x. Either way is fine. Okay, so if we're going to do second derivative then, okay, let's go off of this second version. So we'll do the derivative of our first derivative. So that means we would have first function times derivative of the second, so x plus 1. Now derivative of e to the x is e to the x, plus second function times derivative of the first. Okay, derivative of the first function would just be 1. Okay, so that means we have x plus 1 times e to the x, so that'll be, well, actually we could factor out an e to the x here. We have e to the x, and then we'll be left with x plus 1 and then plus 1, which will turn into e to the x times x plus 2. Okay, so let's write that like how we had the other one. So that's going to be x plus 2 times e to the x. Okay, let's do the third derivative. Let's see if this pattern, I'm starting to sense a pattern, but let's see if this will continue. Okay, so first function times derivative of the second function plus second function times derivative of the first function, derivative of x plus 2 is 1. Okay, which means we could factor out e to the x, and we'll be left with x plus 2 plus 1, which will turn into e to the x times x plus 3. Okay, interesting. Okay, so looking back at this, first derivative was x plus 1 times e to the x. Second derivative is x plus 2 times e to the x. Third derivative will be x plus 3 times e to the x. Okay, everybody see a pattern? So if we're doing the nth derivative, then this will be x plus n times e to the x. And that'll be our answer. Usually when they ask us those types of questions, like what's the nth derivative, find the nth term, that means there's some kind of pattern being established, and it's up to us to figure out that pattern. Okay, so be aware of those types of problems. Let's take a look at our next example. Differentiate the function f of t equals square root of t times a plus bt. Okay. So here we're going to do a product rule. So f prime of t. Now you could also rewrite the square root t as t to the 1/2. Okay, so that means it would be the first function, t to the 1/2, times the derivative of a plus bt. Now derivative of a, it's a constant, so it's 0. Derivative of bt, would just be b plus second function times the derivative of the first. Okay, derivative of t to the 1/2 would be 1/2 t to the negative 1/2. Okay, and that would be it. Okay, let's simplify a little bit. Okay, so here this would be b times the square root of t. Okay, I'm putting this back into square root notation. Plus, and then here, the t to the negative 1/2 would go to the denominator, along with the 2. A plus bt will be on the top. All over 2, and then the t to the 1/2 in the bottom becomes square root of t. So one way to simplify this further is if we were to somehow rationalize the numerator here. Okay, that means we're going to multiply by the denominator. We're going to try to merge these two terms together. So multiply by 2 square root t, top and bottom. And so this would give us 2b, and then square root t times square root t would be t over 2 square root t plus a plus bt over 2 square root t. Now we could combine 2bt plus, picture this as a 1bt. Okay, so we would have a plus 3bt over 2 square root t. Okay, another way to do it, okay, there's a second version. Okay, if you thought about this one, this is also acceptable. So let's rewrite the function square root t times a plus bt. Okay, so let's write that as t to the 1/2 times a plus bt. Now distribute the t to the 1/2. So that means we would have a t to the 1/2 plus b. Now t to the 1/2 times t would be t to the 3/2 using our product rule. Okay, so that's our function. Now take the derivative. So as we take the derivative here, we would do a power rule. So 1/2 a t, and then subtract 1, negative 1/2, plus power rule here, 3/2 b t to the 1/2. Okay, and this would be an equivalent version of our answer that we came up with in the first part. Okay, let's take a look at example 3. If f of x equals square root of x times g of x, where g of 4 equals 2 and g prime of 4 equals 3, find f prime of 4. Okay, so let's then take the derivative of our function. Right, let's take the derivative here. So if we get f prime of x, we'll do the product rule on this. So remember, square root of x is x to the 1/2. So to take the derivative, it would be x to the 1/2 times the derivative of g of x, which will be g prime of x, plus, so first function times derivative of second, plus second function times derivative of the first. Now derivative of the first would be 1/2 x to the negative 1/2. Okay, so just going to rewrite this without the powers, make them square roots. So we have square root x times g prime of x plus g of x, and then we would have x is 2 square root x on the bottom. Okay, so that would be how our f prime of x is defined. Now they tell us some things. They say find f prime of 4. So we're doing f prime of 4. So if we're using this model, then this is what f prime of x is defined as. Right? So that means we could just plug in 4 everywhere we have an x. So square root of 4, g prime of 4 plus g of 4 over 2 times square root of 4. Okay, now they define these for us, right? G prime of 4, g prime of 4 is 3. Okay, so we're going to plug 3 in place of this term. G of 4 is 2. So instead of this term, we're going to plug 2 in here. Okay, so this is going to work out then. Okay, so that means we have square root of 4 is 2. This is 3, so those are going to multiply. Numerator here is 2 over 2, and then square root of 4 becomes 2. Okay, 2 times 3 is 6, plus 2 and the 2 we cancel, so we have 1/2. So we end up with 6.5 or 6.5. Okay, let's take a look at the quotient rule. Okay, so quotient rule is defined a little differently. Let's take a look at it. So here we have the quotient of two functions, and we're taking the derivative. Right, so the derivative of a quotient. Now looking at our quotient rule, okay, it's the denominator function times the derivative of the numerator minus numerator times the derivative of the denominator, all divided by the square of the denominator. Okay, so there's a shorter looking version with u's and v's. Let's take a look at that. Okay, again, u's and v's are functions. Derivative with respect to x of the quotient would be denominator times derivative of the numerator minus numerator times the derivative of the denominator, all divided by the denominator squared. Okay, so let's take a look at an example. So let y equal this quotient. Let's figure out what is y prime. Okay, so let's do, remember it's the denominator times the derivative of the numerator. Okay, so x cubed plus 6 times the derivative of the numerator. Now, derivative of the numerator would be derivative of x squared is 2x, derivative of x is 1, derivative of the constant is 0, minus numerator times the derivative of the denominator. Now, derivative of the denominator is 3x squared, all divided by the denominator squared. Put the denominator in parentheses, squared. Okay, so let's simplify this. Okay, so for the first part here, we'll FOIL these two parentheses. X cubed times 2x would be 2x to the fourth, plus x cubed times 1 is x cubed. 6 times 2x is 12x. 6 times 1 is 6. Okay, minus. Now, what we're going to do is distribute the 3x squared into this parentheses, okay, and keep the parenthesis there. Okay, so we have 3x squared times x squared, which will be 3x to the fourth, plus 3x squared times x is 3x cubed, minus 3x squared times 2 would be 6x squared. Okay, all over x cubed plus 6 squared. Okay, so next what we want to do is distribute that minus sign to our second part there. So we have 2x to the fourth plus x cubed plus 12x plus 6 minus 3x to the fourth minus 3x cubed plus 6x squared, all over x cubed plus 6 squared. Okay, so now we're going to look to combine any like terms in our numerator. So we have 2x to the fourth minus 3x to the fourth. That would be a negative x to the fourth. We have x cubed, a positive 1x cubed, minus 3x cubed. 1 minus 3 is negative 2x cubed. 6x squared, so plus 6x squared, plus 12x, plus 6, and then all over x cubed plus 6 quantity squared. Okay, and that's as far as we would go with that. You don't have to expand the denominator. Okay, just make sure you distribute the minus sign, combine like terms in the numerator, and then you'll be done. Okay, let's take a look at example 6. Find an equation of the tangent line to the curve y equals e to the x over 1 plus x squared at the point 1, 1/2 e. Okay, so I'm just going to rewrite this. Y equals e to the x over 1 plus x squared. And the point is 1 and then 1/2 e. I'll put it as e over 2. Okay, so let's do, since we want the equation of the tangent line, we're going to need to do is figure out the slope and the y-intercept. And luckily they give us a point. Okay, so when we go to point slope form, we have an x1 and a y1. Okay, so let's get the slope then. Okay, so that means let's get the derivative. So we'll use the quotient rule. Okay, so we have the denominator, 1 plus x squared times the derivative of the numerator, which is e to the x, minus numerator times the derivative of the denominator. Now, derivative of 1 plus x squared is just 2x, all over the denominator squared. Okay, so let's simplify the numerator here. We have e to the x on both beginning and ending terms. Let's factor out the e to the x. That means we're left with 1 plus x squared minus 2x over 1 plus x squared squared. Okay, next what we could do is rewrite the trinomial inside, make it look like a regular trinomial. We have x squared minus 2x plus 1. Now you'll recognize x squared minus 2x plus 1. That's a perfect square trinomial. So we have e to the x, and you can factor this, x minus 1 times x minus 1, which we could rewrite as x minus 1 quantity squared. Okay, so this would be the derivative then. Okay, so this is our slope formula. Okay, and let's figure out the slope. Okay, so let's plug in the point that they gave us. Okay, 1 and e over 2. Okay, we're going to plug in 1. Right, that'll give us the slope. If we plug in 1, we have e to the 1, and then 1 minus 1 squared over 1 plus 1 squared squared. Well, 1 minus 1 is 0. And then here this is 1 squared is 1. So we have 0 over 1, which will just be 0. Okay, so our slope is 0. And our point is 1 e over 2. So when that's the case, we have a slope of 0 and a point at 1 comma e over 2. That means we would have a horizontal line, right? And the horizontal line would be y equals e over 2. Okay, we could just easily set up the point slope form, but we would have y minus e over 2 equals 0, x minus 1. So 0 times x minus 1 is 0. And then we add the e over 2 to the other side. And we end up with our equation for the tangent line. Okay, so one of the things to note is every time you see a quotient, don't jump to use the quotient rule. Okay, sometimes it's easier if you could simplify things a little bit in the beginning. You don't have to go through the quotient rule because that's a little bit longer process, not necessary. Okay, so for example here we have 3x squared plus 2 square root x all over x. We just take each term in the numerator and put it over x. And now reduce. Right, so we have quotient rule here. This will just be 3x. Right, one of the x's would cancel from top and bottom. And then here, if we did quotient rule, we would have 2x to negative 1/2 and so it's going to be a lot easier to use the power rule for this equation as opposed to quotient rule for this equation. Okay, so let's take the derivative. That will just get the derivative of 3x is 3 plus derivative here would be negative 1/2 times 2x and then subtract 1, so negative 3/2. So that would give us 3. Now 2 times 1/2, they cancel. So we have a minus here. X to the negative 3/2, so that would be 1 over x to the positive 3/2, or you could do square root of x cubed. Okay, so far this is our table of differentiation formulas. Okay, these should all be familiar now. Okay. There will be others to add to this, of course, as we continue in the course. But make sure you're familiar with these. We got the sum rule, difference rule, product rule, and the quotient rule added on top of our other rules. Okay, that's all for our lesson today. Have a good day. Have a good night. Any questions, email me, and we'll see you soon.